Hi everyone, my name is Amar Zulkarnain and we are a team of 6 UTP students trying to solve the current pressing problem, which is microalgae. So we have designed a solution called CLEAR, Clean Lake Ecosystem Restoration.
Harith, did you smell something?
Yeah, I think I do and it smells bad. Maybe this is due to the algae blooms in the lake.
Is it only happening here?
I don't think so. Algae blooms are common issues in many lakes due to nutrient buildup and poor water circulation.
Critical lake. I think we should tackle this issue.
Yeah, I think so.
Let's go.
So let's see our problem statement. UTP is currently facing an algal bloom crisis in its main campus lake, and the stagnant water body has shown excessive algae proliferation, resulting in murky green coloration and surface scum formation. So these such conditions are because of eutrophication, typically driven by elevated nutrient concentrations and limited water circulation. So what is our root causes? First is excessive nutrient loading, poor water circulation or stagnation, environmental and climate factors, and last but not least is biological imbalance. So why HAB is growing nowadays? What is HAB? HAB is harmful algae bloom. So basically, HABs are increasing threatening freshwater ecosystems, human health, and water-dependent economies. The main cause is because of eutrophication and rising water temperature due to climate change. So the main drivers of HABs are anthropogenic nutrient loading, the climate change and rising temperatures, and the little to no water flow. So do you know what is the consequences of not treating HABs? First is the oxygen depletion and aquatic hypoxia. Second, light penetration blockage. Third, ecosystem destruction and biodiversity loss. Fourth, toxic contamination. And last but not least is odor and aesthetic degradation. The scope and boundaries of the problem. HABs is a global problem where it occurs worldwide, transcending geography and political boundaries. So the main drivers of it is eutrophication, temperature changes, and stagnant water, and it can appear wherever these conditions converge. So our project focus is within campus environment. This project focuses on HABs in a campus lake, and it allows a strategic, controlled study while keeping broader applicability. So our target site identification is first visible algae bloom on water surface, evidence of eutrophication from nutrient accumulation, stagnant or slow-moving water, and in this near potential nutrient sources. So proof of concept development, our campus deployment phase 1 of broader vision. So our demonstrations are a technical feasibility of solution, operational protocols and best practices, performance metrics and efficiency benchmarks, cost effectiveness data, and lastly, scalability for larger deployment. Our main objectives are first, prevent HABs from spreading by maintaining healthy water quality and balanced nutrients. Second, continuously observe HABs and water conditions to understand and predict blooms. And last, reduce algae in the water to protect the ecosystem and maintain usability.
Let us now move on to the feature overview of our solution. So first of all is the hull configuration where we employ the catamaran configuration. We have computed and we have unanimously agreed to have 2.5 m times 1.5 m times 0.6 m dimension because this gives high stability against rotation, winds, waves, and even disturbances. And the materials for our solution would be 3D printed PLA with waterproof coating because it is cost effective as well as lightweight. It is inspired by Smart Boat 5. Second is the dual thruster with high maneuverability and redundancy, and this improves the efficiencies. The motors of it is the brushless DC, and the propeller's specs would be 10 to 12 diameter. Third is the ECF reactor system. This is the core component of our solution where it clumps together the HAB to ease the process of collecting the HAB on the surface of the water. So we have computed and carried out the literature review, and we discovered that 60-degree tilted alignment will give the highest harvesting efficiency, which is up to 60% of efficiency in 2.2 minutes. Dimension would be as you guys can see on the slides, and then the electrode specification as well as power supply have been completed as well as compared with the literature review. The fourth one would be the collection and disposal system where we will employ water suction to avoid any physical contact and facilitate the process of collecting the clumped algae. And then we will also be having a mesh filter that is easily detachable for algae collection. The fifth one is the computing and control system, which mainly decided by our computer engineering student. But the core component would be NVIDIA Jetson Nano, Raspberry Pi Pico, or even Arduino Mega or OS. And then the sixth one would be the sensor suite, where we have three types of sensor: navigation, perception, and monitoring, all of which are important to ensure that this solution can maneuver by itself, as well as using the controller. And then the last one would be the power distribution, where every magical things starts from here. We have computed and we have determined the specification and power requirement for propulsion motors 400 watts, TCF reactors 250 watts, collection system 50 watts, computing and sensor 50 watts, all of which can be gathered by our battery, which is 1500 watt per hour.
The value proposition. Firstly, we talk about the environmental impact, which is prevent harmful algae bloom in the campus lake, keeping water clean and safe for aquatic life, maintain oxygen level, sunlight penetration, and overall ecosystem balance, supporting fish and other organisms, which is use efficient removal technique without harmful chemical, preserving natural water quality. Social impact, reduce no toxin, microcytin, safe for adult, protecting students, staff, and nearby communities. Offer interactive HAB controller session, which is visitor can clean algae themselves for 5 ringgit per 15 minutes. The cleaning algae, fish are introduced and visitor can feed them using purchased fish food. Promoting learning and recreational enjoyment. Next, educational and research value, fully compliant with Malaysian National Water Quality Standard, the Environmental Quality Act 1974, ensure safe, transparent algae removal and water quality monitoring. Real-time tracking of HABs, ensure accountability and early invention. Last, economy and long-term value, revenue opportunities, controller session fee, fish food sales, and interactive eco-learning experience. Tourism and campus appeal, a clean, interactive lake attracts student, visitor, and eco-tourists, boosting engagement and campus visibility. Lastly, a scalable model. Proof of concept demonstrate how this approach can be replicated in other lakes, combining environmental sustainability, community interaction, and profitability. That's all.
This lake is part of our campus and part of our community. It's all up to us to care of it. Together, we can make it beautiful, clean, and safe for our community. Thank you.